Hello, hello, hello. Good morning. I have a ton of errands to run today, so my stream will be a little bit on and off. 12:15 is the first time I have to leave the house. But I will try to get some things done, especially I want to watch the new video from Brackeys. And maybe we can learn something about video effects. Would be amazing if we could learn how to make proper explosions for our rocket launcher, missile launcher. Uh, we can maybe we can improve upon our laser, do some other stuff. We'll see. Anyways, let's first view the tutorial and then make a couple of notes during it if there's anything we can apply to our game, and then pay extra close attention to any parts that is applicable to us, and maybe try it out in practice. The docs. Okay. Okay, remove this. Open the chat here.
I think few things in game dev are as fun as making things go pow, boom, or well, shh. Today we're diving headfirst into the world of VFX in Godot. We'll learn about the tools at our disposal for creating all kinds of cool effects from magic to rainfall, and how you can quickly start putting together effects of your own. And at the very center of VFX in Godot is the powerful particle system, something that can be a bit intimidating because of the many settings, but we'll look at how you can start simple and then layer more stuff on top as you get comfortable. We'll break down a bunch of VFX to learn some interesting techniques that I personally find really useful, and we'll make our own in both 2D and 3D. I know that's a lot to cover in just one video, so to make sure that it doesn't get too overwhelming, let's light this ceremonial video torch, and then I promise the video will be over before it burns out. Now, when working with VFX, I like to have a small library of assets ready to experiment with, especially textures. So I've gone ahead and bundled together a bunch of my favorites into an asset pack that you can download for free using the link below. It contains all of the assets that I'll be using in this video, from sprite sheets with cool pixel art effects, to textures that are perfect for particles, and even some flipbooks. Everything is under the CC0 license, so it's free to use and there's no requirement to credit. Thanks to the original creators on the screen now for making these available in the first place. Alright, let's start this video off with a bang and talk about explosions. But first, this video is sponsored by Senma. If you want to make your own games in Godot, make sure to check out Senma Academy. They offer great beginner and intermediate courses, including a free introductory course on Godot. Senma combines fun and practical learning through professional video tutorials, written lessons, and interactive quizzes. And what's really cool is that you'll be building real projects across various genres from RPGs to bullet hells. Senma also has a wide range of courses on Python, Unity, Unreal, and other essential tools. With a single subscription, which includes a 7-day free trial, you unlock over 300 courses. Use the coupon code below to get an extra 20% off the first year of your Senma subscription, on top of any existing site-wide discounts. The offer is valid for the first 50 subscribers, so make sure to use your coupon today to start your game dev adventure. So before we open up Godot, let's have a look at what normally goes into making a visual effect. When I make effects, I like to think of it like I'm working with layers. I create one layer at a time and combine them to achieve the final effect. I like this way of working because it allows me to start with just a single layer, and then slowly build on top until I reach the level of detail I'm going for. For a simple 2D explosion, for example, you can get away with using a single layer, an animated sprite 2D node with a sprite sheet, and then maybe an audio stream player to play a sound. But for a more complex explosion, you can have many layers. Particle systems for fires, smoke, sparks, debris, a shockwave. You might have an omni-light, sounds, and an animation player to time everything. But how do we make each layer? Well, for simple effects, especially in 2D, all you need is a good sprite sheet that you can display with an animated sprite node, which means that you can actually start making VFX by just hand drawing each frame of your effect in a software like Sprite or GIMP. This can be a little time consuming, but it's also a nice and simple way of working, because what you draw is what you see in the end. However, this creates very static effects, because we're showing the same sprites every time. And if you're working in 3D, you might want something that feels a bit more, well, three-dimensional. Which brings us to particles. Particles are awesome. Why? Well, a particle system spawns particles. We can apply forces to these particles, animate them over time with things like color and size, apply textures to them, and really create some cool effects just by changing properties in the inspector. Because particles are simulated in real time, it's super easy to add randomness and variation. And unless you completely overdo the amount of particles, they're actually really fast to render. Now, I should mention that VFX artists often write their own shaders and combine them with particles for more flexibility. But while custom shaders don't have to be massively complicated, they would be hard to cover in this video before the torch burns out. So we'll leave it for another one. Instead, we'll focus on the many effects that we can create with just a few particle systems and a good amount of creativity. Which means that to make cool effects, we need to learn how to particle system. I'll show a few things in 2D and then move on to 3D, but when working with particles in Godot, the core concepts between the two are very similar, so I wouldn't worry too much about it. The first step is to create a particle system. So we go add node, and here we
Let's just make a quick note that at 5 minutes the first tutorial starts.
have two different nodes to choose from, CPU and GPU particles. As the name suggests, CPU particles are simulated on the processor and GPU particles are simulated on the graphics card. And I would say, if in doubt, use GPU particles. The main reason not to use them is if you're targeting low-end hardware, such as mobile devices. You can always convert a GPU system to a CPU one using this option at the top. We'll focus on GPU particles since they allow you to create more complex effects with greater performance. And right away we can see that our particle system should be emitting, but there are no particles. That's because we need to go under process material and add a new particle process material. And now we can see some tiny particles. And under the process material, we get a scary amount of settings that change all kinds of things about our particles. For example, we can go under spawn velocity and set the initial velocity to something like 100. We can also set the spread to 180 to make the particles fly in all directions. The process material really is where the magic happens. And the cool thing is that it's the same from 2D to 3D. But before we get lost in the power of the process material, at the top here we can adjust the basic settings of our particles. We can set the texture. I'll use this one from the assets, the amount of particles to emit, and under time, we can set the lifetime of each particle. Here we also have the option to limit the particles to a fixed FPS. We can increase this to 60 to make it
Let me know if the sound of the video is too low or something.
appear more smooth, or just set it to 0 to remove the limit altogether. Some effects like explosions happen in bursts, and for this we can use the explosiveness. Right now it's set to 0. If we change it to 1, all particles will emit at the same time. Or we can choose a value somewhere in between. Of course, most explosions don't repeat like this, so we can set the system to one shot and it will only play once. We can then use emitting to make the particles play. Alright, on to the good stuff, the process material. Most of the process material can be split into three main categories. The first is spawn, how the particles start. Here we control where the particles emit from, at which angle in case we're using a texture where we can see how it's rotated, and at what velocity. We've already used this to quickly increase the initial velocity to make the particles spray out further. The second category is display, what the particles look like. Here we can control things such as scale and color of the particles. We can of course set these to a constant value. We can go under scale and set the min and max values to 0.2 to make the particles smaller. Or we can add variation by setting the two values to something different. And now our particles will vary between them. And even cooler, we can use a curve to change values over time. So under scale curve, we can set a new curve texture, go under curve, and draw out how we want the scale to change over time. Here, for example, the particles start small, quickly grow to their full scale, and then slowly shrink away. Creating variation and changes over time this way is incredibly powerful, and we can do it to modify all kinds of things about our particles. For color, for example, we can go under color curves and use a color ramp. Here we create a gradient texture that changes the color over time, which as you can see can immediately make our particles look 3 times cooler. And we can of course alter the gradient as we see fit. The third and final category is animated velocity and accelerations, how the particles move and rotate over time. While we can set the initial velocity of our particles in the spawn category, if we want this to change over time, this is the category we need. Take this particle system. It has no initial velocity and no forces acting on it. All the particles remain in place. Now we can use animated velocity to directly set the velocity in all kinds of ways. For example, we can go under directional velocity and set this to a value between -200 and 200. But nothing happens. That's because here we need to use a curve to set the velocity of each axis. So I'm going to create a curve for the x-axis and have it start really high and then decrease. And now our particles will shoot out and then slow down along the x-axis. We can also use accelerations to more indirectly affect velocity using physical concepts. This particle system has some initial velocity. We can then apply gravity and damping. So that's the 3 main categories. I think the rest of the settings are a bit more situational, so we'll look at those as we go. And that's how the particle system, which means we are ready to go 3D and try some of these things out. Let's start with more.
Maybe we should make a couple of notes on these things.
The third and final category is animated velocity and suggests CPU. We can also set the spread animated on the processor.
The use GPU over CPU unless working on mobile.
And GPU particles are simulated on the graphics card. And I would say, if in doubt, use GPU particles. The main reason not to use them is if you're targeting low-end hardware, more complex effects be emitting material particles that change all kinds of things in the process material. And now we can see some tiny particles and particle process material. Because we need to go under process material and add a new particle process material. And now we can see some tiny particles. And under the process material, we get a scary amount of settings that change all kinds of things about our particles. For example, we can go under spawn velocity and set the initial velocity to something like 100. We can also set the spread to 180 to make the particles fly in all directions. The process material really is where the magic happens. And the cool thing is that it's the same from 2D to 3D. But before we get lost in the power of the process material, at the top here we can adjust the basic settings of our particles. We can set the texture. I'll use this one from the assets, the amount of particles to emit, and under time we can set the lifetime of each particle. Here we also have the option to limit the particles to a fixed FPS. We can increase this to 60 to make it appear more smooth, or just set it to 0 to remove the limit altogether. Some effects like explosions happen in bursts, and for this we can use the explosiveness. Right now it's set to 0. If we change it to 1, all particles will emit at the same time. Or we can choose a value somewhere in between. Of course, most explosions don't repeat like this, so we can set the system to one shot and it will only play once. We can then use emitting to make the particles play. Alright, on to the good stuff, the process material. Most of the process material can be split into three main categories. The first is spawn, how the particles start. Here we control where the particles emit from, at which angle in case we're using a texture where we can see how it's rotated, and at what velocity. We've already used this to quickly increase the initial velocity to make the particles spray out further. The second category is display, what the particles look like. Here we can control things such as scale and color of the particles. We can of course set these to a constant value. We can go under scale and set the min and max values to 0.2 to make the particles smaller. Or we can add variation by setting the two values to something different. And now our particles will vary between them. And even cooler, we can use a curve to change values over time. So under scale curve, we can set a new curve texture, go under curve, and draw out how we want the scale to change over time. Here, for example, the particles start small, quickly grow to their full scale, and then slowly shrink away. Creating variation and changes over time this way is incredibly powerful, and we can do it to modify all kinds of things about our particles. For color, for example,
Yo,
we can go
Headboop
under color
Games,
curves
welcome.
and use a color ramp. Here we create a gradient texture that changes the color over time, which as you can see can immediately make our particles look 3 times cooler. And we can of course alter the gradient as we see fit. The third and final category is animated velocity and accelerations, how the particles move and rotate over time. While we can set the initial velocity of our particles in the spawn category, if we want this to change over time, this is the category we need. Take this particle system. It has no initial velocity and no forces acting on it. All the particles remain in place. Now we can use animated velocity to directly set the
I'm good this Monday, thank you. I have a pretty big list of little errands to run today. So I was streaming till 12:15, and then have to run some errands for a couple of hours. Then I'll stream like 2 or 3 hours, do some errands, maybe stream in the evening. I'll be on and off. How are you this Monday? Tell me if the video is not loud enough.
velocity in all kinds of ways. For example, we can go under directional velocity and set this to a value between negative 200 and 200. But nothing happens. That's because here we need to use a curve to set the velocity of each axis. So I'm going to create a curve for the x-axis and have it start really high and then decrease. And now our particles will shoot out and then slow down along the x-axis. We can also use accelerations to more indirectly affect velocity using physical concepts. This particle system has some initial velocity. We can then apply gravity and damping. So that's the three main categories. I think the rest of the settings are a bit more situational, so we'll look at those as we go. And that's how the particle system, which means we're ready to go 3D and try some of these things out. Let's start with this 3D explosion inspired by an awesome video by Legion Games. This effect is made up of a bunch of different layers.
The video is not dominating. You almost can't hear it. Okay, let's see if we can fix that. So the desktop audio, we go properties, filters. Maybe add gain. I have no idea if this is gonna be loud or not, so I'm sorry if it is loud. But this is Brackeys video, yeah. Let me just try to look
Let's
at it.
start with the fire layer. So I'll create a new GPU particles 3D node.
It seems to be running at like minus 27, and my voice is running at about minus 8. Is it good? Because it looked like it was a little low still. Is it going to be too loud if I turn it up more? Yeah. But it's very easy to change it. If it's a little low, we'll just fix it. This might be too loud though. Let's see. Filters 30. So now it's 20 decibels higher.
We can't see anything yet, so just like in 2D, we should add a process material, but still nothing happens.
This looks like it's the same volume as my voice almost. So I think this is correct, but you tell me if it's too high or too low.
Which means we are ready to go 3D and
A little louder than I am. Could be fine. But let's put it at like 25 then.
try some of these things out. Let's start with this 3D explosion inspired by an awesome video by Legion Games. This effect is made up of a bunch of different layers. Let's start with the fire layer. So I'll create a new GPU particles 3D node. We can't see anything yet, so just like in 2D, we should add a process material, but still nothing happens. That's because in 3D, we need to tell the particles what kind of mesh to render. We do this by going under Draw Passes, Pass 1, and choosing a mesh. For standard particles like in 2D, we can use a quad, but we also have options for other meshes like spheres, boxes, and we can even drag in a custom mesh if we want to. I'll choose a sphere, and immediately we can see our particles. Just like any other mesh, we can add a material, and here we can actually use a regular standard material 3D. We can leave all the settings as is, but one thing that we will
Okay, so we add a draw pass when we do in 3D. Must have setup. Mesh to render.
standard material 3D. We can leave all the settings as is, but one thing that we will definitely want to do is go under vertex color and enable use as albedo. In fact, let me leave this off for now so you can see later why it's important. So for the base settings, we'll increase the amount a bit, make the particles explosive, and let's just set fixed FPS to 0 for optimal smoothness. Under Spawn, Position, I'll set the emission shape to sphere. This means the particles will emit inside the sphere.
Emission shape in Spawn.
Just like earlier, I'll give the particles some initial velocity and increase the spread to make them emit in all directions. Then, under accelerations, I'll set the gravity to a small positive number to make the particles slowly drift upwards. And at this point, the particles all look the same. So I'll go under Display, Scale, make them a bit smaller, and give them some variety. I'll also add a scale curve to make them shrink over time. To give our particles color, we can go under Color Curves and set a color, except nothing happens. That's because I left Use as Albedo off in the standard material. So if I go
Use as albedo. Use. Yeah.
vertex color used as albedo, the
And that's under vertex color. Yeah.
color appears. This is because the particle system is modifying the mesh's vertex colors, and so we need the material of the mesh to show those vertex colors. But we don't just have to choose a fixed color. We can get a random color from a gradient using color initial ramp. Here I'm just creating a gradient that will add a little bit of variety to the color. And we can make the particles brighter using an emission curve. I'll draw a curve that starts high and then falls off. Note that you can change the maximum value of the curve if needed. If you have a world environment that is set up to use glow, the particles might even start glowing. If you want to learn more about setting up glow and the world environment, check out our video on making 3D games in Godot. Finally, we can mark our effect as one shot. And that's the first layer. As you can see, most of the properties we've set are the same ones I showed you for the 2D particle system, and we can use the same ones for creating all the other layers and most effects in general. In fact, to create the smoke, I duplicated the fire layer and just increased the lifetime a bit, decreased the initial velocity, increased the gravity, and changed the color to a dark gray, and immediately it looked like smoke. Note that whenever you duplicate a particle system to create a new one, there are some pitfalls to avoid. And I find they are as confusing as they are stressful. So let me put on some calming music and guide you through it. After duplicating a particle system, you have to be careful to also right-click on the process material and select Make Unique Recursive.
Okay.
This is because the process material is a resource, and so it will be shared by both the original and the duplicated particle system. So any changes you make to the new one will also change the original, which is probably not what you want. Because we chose recursive, we can see all the sub-resources here as well.
What I often ended up doing in Godot, when I make a copy, instead of making a copy of something, I often just make it from scratch again. And if there's like usually I can copy paste certain things, but I'm always scared of this shared resource system that I would accidentally change like the size of a different collision box when I change an unrelated collision box, because once upon a time I duplicated something and now they use the same resource or something like that. So if you're gonna duplicate things in Godot, you better know stuff like this, how you make it unique.
We'll make all of them unique, so let's press OK. And now some of you might be thinking, what about the mesh in the draw pass? That's also a resource, and so we should probably make that unique as well. However, making the mesh unique is not great for performance. It's best if we can share the same mesh between the particle systems that use it. But our mesh holds the material, so what if we want to make changes to the material? Well, instead of assigning the material to the mesh, we can assign it to the node, down under Geometry, Material Override. This way, if we need to change the material, we can make it unique while still sharing the same mesh. This is a trick that was just pointed out to me, so you'll not always see me doing this in the video, but I definitely recommend to assign the material here.
Okay, so if we want unique material, it's better for performance to use geometry material override and to actually make a unique material.
Here. A final thing to note is that if a material uses a texture, which we'll be doing a lot, and we select Make Unique Recursive on the material, we need to uncheck the texture. Otherwise, the texture also becomes unique, and that is not great, because then instead of loading the texture regularly, Godot will embed it into the scene, and so the scene gets bloated with a bunch of texture data. Don't worry at all if that made you very confused, just remember to avoid making textures unique if you can. Now, the only thing that I did that was special for the smoke was that I made it fade in and out by adjusting the alpha over time with a curve. In order for this to work though, you have to go into the material and set transparency to alpha. If you want to get really fancy, you can also enable turbulence and play around with the settings to make it seem like particles are getting caught in the wind. And that's it for the smoke layer. Now, when I'm making particle effects, I constantly need to preview my changes. And when working on one-shot effects, having to toggle emitting on all the time is a little cumbersome. Instead, we can go here to GPU Particles Restart Emission. The shortcut for this is Ctrl-R. But still, previewing multiple particle systems at the same time gets very awkward. In this case, for example, I'd love to see the smoke and fire layer play together. So until Godot gets some built-in tooling for this, I've made a plugin that you can use. I call it Brackeys Particle Controls. You can download and add it by just dragging it into your project. Like any other plugin, just make sure to also enable it under Project, Project Settings, Plugins. As you can see, I can now play and stop particle effects. I can turn on looping to have the preview loop. This doesn't change anything on the particle system itself, it's still set to one shot, so no worries there. I can also pause and scrub through the effect. And using these buttons on the right, I can choose to include neighboring or child particles as well, which is perfect for playing multiple layers at once. I've made the plugin available free of charge and open source under the MIT license. Hopefully we'll see something similar be built into the Godot engine in the future. To toggle emitting on all the time is a little cumbersome. Instead, we can go here to GPU Particles that you can use. Stop particle effects, it by just dragging it into your Go get some built-in tooling for this. Smoke and fire layer play together very often. Toggle emitting on preview my changes layer.
So what
Work
is this?
for this is control very
Let's see how we can
so
download
call it
this.
Brackeys
Brackeys particle controls. I'm sure there is a link down here. Yeah.
particle controls. You can download and add it by just dragging it into your project. Like any other plugin, just make sure to also enable it under Project, Project Settings, Plugins. As you can see, I can now play and stop particle effects. I can turn on looping to have the preview loop. This doesn't change anything on the particle system itself, it's still set to one shot, so no worries there. I can also pause and scrub through the effect, and using these buttons on the right, I can choose to include neighboring or child particles as well, which is perfect for playing multiple layers at once. I've made the plugin available free of charge and open source under the MIT license. Hopefully we'll see something similar be built into the Godot engine in the future. Now to make the spark layer, I again duplicated the fire. I increased the amount, reduced the lifetime, gave them a good amount of initial velocity, and a bit of gravity. The main thing I did differently here was that I used a cylinder mesh for the draw pass. By changing the top and bottom radius, I turned the particles into 3D spikes. But as you can see, they weren't facing the right way. To make particles point in the direction of travel, we go under particle flags in the process material and set a line Y to be true.
Okay. We have process material. Particle flags. Set to true. We face the particles in the direction they travel.
I also gave them an orange color and some emission on the material itself, since I didn't need to use a curve to change it over time. For the shockwave, the technique is a little bit different. Again, we are changing the same settings, but this time we are only emitting a single particle. This might seem a little weird at first, but it's actually very common to use very few or even just a single particle to make parts of an effect. In this case, I wanted to create a flat shockwave that would expand quickly and then disappear. So I set the amount to 1, the lifetime to half a second, and then to make the particle appear as a wave, I used a quad mesh for the draw pass. I changed the orientation to face Y to make it horizontal and gave it a new standard material. And now under albedo, I could supply a texture. So I used this ring texture. To get rid of the background, I set the transparency to alpha, and since I didn't want the shockwave to be affected by light and shadow in the scene, I went into shading and set the mode to unshaded. I then got rid of the gravity, scaled up the particle, and made it expand using a curve. I also made it fade out with an alpha curve. For this to work, we need to remember to set vertex colors to true. Finally, a neat trick when using 2D elements in a 3D effect is that you can set the cull mode to disabled. This will make sure that you can also see the effect when looking at the back side of the quad, which is normally called the
Ah, okay.
make sure that you can also see the effect when looking at the
Cull mode disabled.
cull mode to disabled.
I remember when I made my shield for my base. Then I think I actually made a outside shield and an inside shield to get past this. You can only view it from one side. Let's see. I have the subtraction. No. Actually, it looks like I do only have a single mesh instance, which is as a CSG sphere, and then I just removed the middle of it, make just a outer shell. Then I remove the bottom of it to make it only be above the ground. Okay. cull mode back. Well, we can see it from the inside and the outside. Seems like. In the world, the shield. Let's just turn it disabled for now and see how it changes things. I'm not sure if it changed anything. Okay.
Disabled. This will make sure that you can also see the effect when looking at the back side of the quad, which is normally called away.
Okay, so quad mesh. Usually visible from one side. Set culling mode from back to disabled.
And at this point, the effect is already looking pretty good. But for a big effect like an explosion, it can feel weird if it just suddenly happens and then disappears. So we need something that will stick around a little bit, showing the impact of the explosion that just occurred, such as debris. And again, this layer was made by slightly modifying all the same settings. The only thing of note here is that for the draw pass, I used a prism mesh to make the pieces feel more, well,
You know, we can probably use this particle system to simulate when we break rocks as well, when we mine them. I'm just a bit curious if you can have these particles use collision so that they will, for example, stop when they hit the ground, or how that works.
debris-like. And then of course they needed to collide with the ground. And this is where particles actually have a pretty big limitation. Because they're simulated on the GPU, they can't interact with the physics system which runs on the CPU. They simply have no way of knowing that the floor here has a collider. So instead, we have to tell the particles that there is something here to collide with. We do this by adding a GPU particles collision node. These are special collision nodes that the GPU particles can see. There are actually a few different types for different shapes, but in this case a box is all we need. I just lined it up with the floor. And now in the process material we can turn on collision and adjust friction and bounce as needed. Note that there is also a setting hiding in the base particle settings for adjusting the size of the collision sphere that the particles use. So if particles
Okay, so this kind of workaround I can imagine works very well if you have like you would kind of have to know how far it is from the thing you break down to the ground, since it seems like this. Or would you add this GPU particles collision box to, for example, the mining blocks? So that let's say that the GPU particles collision box lives in another node. Yeah, you see it already does, right? Because the debris is down here under the mesh explosion, while the GPU collision box is over here as a sibling of mesh explosion. So they're not under the same node already. So I imagine what we can do is like have the mining block with the GPU particles collision box on them, and then when we spawn debris, the debris will actually stop at any mining block. And I think that might be how we can do that. Try adding it to let's see, we can write down here. Debris from mining blocks. Bonus particle effects. Add GPU particles collision box to objects in the mine. Without this, the particles cannot recognize what to collide with. As the normal collision system is rendered on the CPU.
Appear to be floating or sinking into the floor, we can adjust this. Okay, let's take a quick break to check in with this ceremony.
Just collision size. If it seems like particle debris goes into the floor. Okay.
O'Neill video torch. Still burning bright, that's good. But I think it's getting time to move on to something other than this explosion. Say magic effects. But let me just show you how to take all of these particle layers and put them together to use in-game. This can be done through script, which we'll look at later, but an easy way is using an animation player. With an animation player node, we can make a play animation where we trigger all the particle systems. I just add a keyframe for emitting at the very start of the animation. Doing this in practice can be a little clunky because Godot will disable emitting when the particle system is done, so we might need to keyframe emitting being off, then select the keyframe and change the value to on. A little weird, but it works. And after doing this for all the particle systems, we can play them together.
Okay, so we might be doing it through script, but animation player to trigger multiple particle effects. Create new animation player. Target each particle effect. Click the key by emission. Set the true at animation player frame 0.
And we can even use this to do cool things like offset them. For example, in VFX, it's common to use some kind of wind-up. This is a layer that builds up to the main effect, like a swirling of energy before a magical blast. Here I have a wind-up effect of some energy contracting that I'd like to play before the explosion. So in this case, we can simply move over the keyframes for the rest of the particles and keyframe the wind-up to start immediately. We can also use our animation player to combine our particles with other nodes. Here I've added an omnilight that I animate to get really bright and then slowly fade away. I think it really helps the effect tie in with the rest of the world. And the explosion is looking pretty good. It could definitely do with some sound, but we'll get to that. But the effect is very stylized and has a hard 3D mesh look, which might be what you're going for. But what if we want to make softer looking effects like this magic puff? Well, for this, we need to use billboarding. Billboarding is a very common technique for displaying particles in 3D space. With billboarding, we use regular 2D textures, show them on a quad mesh, and then have the mesh always rotate to point towards the camera. This results in flat 2D particles that we can move and manipulate in 3D space. It's highly performant and very powerful. To set up a particle system to use billboarding, we add a quad mesh to the draw pass, and as usual add a standard material. Then we go all the way down to billboard and set this to particle billboard. And voila! The particles are now facing the camera and set the particle system to use billboarding, we performant and very powerful.
Okay.
To set up a particle system to use billboarding, we add a quad mesh to the draw pass. To set up a particle system to use billboarding, we add a quad mesh to the draw pass, and as usual add a standard material. Then we go all the way down to billboard and set this to particle billboard. And voila! The particles are now facing the camera. Note that if you are scaling the particles in the process material, it's going to seem like it isn't working. To fix this, we enable Keep Scale, and now your scale changes should apply. And so we can apply a texture on the albedo and start configuring the particles to our liking. For the first layer of the magic effect, I used this texture. Otherwise, I used pretty much all the same techniques as when making the fire for the first explosion. I did create a scale curve that was a little bit different. I made the particles quickly expand, followed by a bit of a spring effect that I really liked. And then of course, I faded the particles in and out with an alpha curve. Oh, and a nice setting is this lifetime random, which will create variation in the lifetime of the particles. But the particles are looking a little flat, which brings us to the next trick: blend modes. By setting the blend mode on a particle's material, we can control how the colors of the particle are blended with what's behind it. By default, Godot uses a mix blend mode, which results in the color behavior we're used to seeing. But light effects, such as fire or magic, will often use another blend mode: add. With this blend mode, the colors are added to what's behind it, which results in bright spots getting even brighter. It also means that the darker the color, the less visible it is. There are also other blend modes such as subtract or multiply, which are mostly used for artistic effects. Feel free to play around with them. So for a magic poof like this, I will probably use add for fire and sparks and mix for smoke and debris.
This is it under the
Use
material
add
or
blend mode, the dark behind the blend mode. Add.
yeah, material blend mode.
With this blend mode, the colors are added to what's behind it, which results in bright spots getting even brighter. It also means that the darker the color, the less visible it is. There are also other blend modes such as subtract or multiply, which are mostly used for artistic effects. Feel free to play around with them. So for a magic poof like this, I will probably use add for fire and sparks and mix for smoke and debris. Now, when using billboards, a common pitfall is that the particles look too static. Most of the time, we don't want it to be clear that each particle is just an image. A trick that I use to combat this is adding a random start rotation to the particles. I'll just set an angle between 0 and 360 degrees. And I might also add a bit of angular rotation over time under animated velocity. This can help a lot, but it might not be enough, in which case we can use animated textures, which we'll do in just a second. Next, I added a smoke layer using the same techniques and this texture. And sometimes you want the particles to be affected by the lighting in the scene, and sometimes you do not.
So the power of the billboarding is basically allows us to use 2D, is it meshes? Textures in a 3D space. By always facing the mesh or the texture towards the player.
For unlit particles, we go to the standard material and set shading mode to unshaded. This is great because it's super performant and your particles will look the same in any lighting environment. However, the drawback is that your particles will look the same in any lighting environment, so you'll have to adjust the effect manually if you change the lighting. If you do want your particles to be affected by lighting, we leave the shading mode at per pixel. And what I will often do is actually change the diffuse mode. This allows us to choose which algorithm to use for diffuse light scattering. And I found that Lambert Wrap or especially Toon work really great for stylized particles. I think they tend to result in less contrast between light and shadow. And since particles are rarely shiny, we can just set specular mode to disabled. And now that our
So this is again material. There's a lot of things that goes under material here. We have transparency, blend mode. Shading. Often used settings.
particles respond to lighting, we can add lights to the effect itself, which can really help bring it to life.
Ooh, yeah.
I also added some glowing balls using
That's a good idea. Hmm.
the same texture as the smoke, some plasma-like debris, and some tiny sparks with this spark texture. Because I was using billboards though, I couldn't use the align Y particle flag to make the particles face the direction of travel, because then they wouldn't face the camera properly. Instead, I had to go under drawing and set transform align to Z billboard plus Y to velocity. And now the particles were billboarding and also orienting themselves correctly. Finally, to make a shock wave, I created because then they wouldn't face the camera properly. Instead, I had to go under drawing and set transform.
Okay, so for billboarding, have particles face the direction they're moving. Special for billboarding. Go to drawing. Transform a line.
Align to
Set billboard plus Y to velocity.
Z billboard plus Y to velocity. And now the particles were billboarding and also orienting themselves correctly. Finally, to make a shock wave, I created a particle system with a single particle and used a sphere with an unshaded material for the draw pass. Then it was as simple as having it quickly expand while fading out. I combined all of this with an animation player and an OmniLight to really sell the effect. And the cool thing is that this effect is super easy to create variations of.
Alright, head boop games. Has to be done.
If, for example, we wanted a fire explosion instead of this magical poof, it's as simple as tweaking a few settings, mainly color, and we can very quickly get something like this. But again, the sprites themselves are looking a bit static, especially the flames are pretty clearly just images rotating around. Luckily, just like we use sprite sheets to animate regular 2D sprites, we can also use them to animate particles. These sprite sheets are sometimes referred to as flipbooks. To apply a flipbook texture like this one here, we need to first set up the material to use it, and then we can play the animation. And the settings for this are a little bit hidden in the interface. In 2D, we assign the flipbook texture to the texture slot. We then scroll all the way past the particle stuff to material, where we can create a new canvas item material. Inside it, we enable particles animation, set the number of horizontal and vertical frames in our flipbook, and choose whether we want it to loop. In 3D, we go to our standard material and drag the flipbook into the albedo texture. We then make sure that the billboard mode is set to particle billboard or the animation settings won't show. Here we also set the horizontal and vertical frames and looping. And now, for both 2D and 3D particles, we can play the animation. This is done in the process material under display animation. If we set the speed to 1, the animation will play through once during the particle's lifetime. And immediately we can see the life that this can add to our particles. And here is the same explosion, but using a sprite sheet for the smoke layer as well. Now sometimes when you're using multiple particle systems with transparent materials like I'm doing here, sometimes and now
Okay.
here we and drag the flipbook into the albedo texture. We go to our book and choose whether we want it to loop. In 3D, we go to our standard material whether we want it to loop. In 3D, we go to our
Animated particles.
standard material and drag the flipbook into the albedo texture.
Okay, so uh, animated particles use what we call a flipbook. A bunch of textures. Showing different showing the texture at different points in its lifetime. Imagine 8 images making a running animation. Or a fire animation. Burning fire animation.
We then make sure that the billboard mode is set to particle billboard or the animation settings won't show. Here we also set the horizontal and vertical frames
So horizontal frames and vertical frames must be set to match the number of images making up the texture. Flipbook. Something like that.
and looping. And now
He turned off looping. He says looping, but he turns off looping, so I'm not sure what that
set
means.
to particle billboard or the animation settings won't show. Here we also set the horizontal and vertical frames and looping. And now, for both 2D and 3D particles, we can play the animation. This is done in the process material under display animation. If we set the speed to 1, the animation will play through once during the particle's lifetime. And immediately we can see the life that
Okay, so in the process material, this is gonna use both material stuff. This is like everything done in the material. And then In the process material, go to animation, speed, tells how many times the entire animation should run during the lifetime of the particle. This is what I more assume.
That this can add to our particles lifetime. We set the speed to 1, the animation will play through once during the particle's lifetime.
Yeah.
And immediately we can see
How many times the entire animation should run during the lifetime?
the life that this can add to our particles. And here is the same explosion, but using a sprite sheet for the smoke layer as well. Now, sometimes when you're using multiple particle systems with transparent materials like I'm doing here, you can get issues with Z-fighting. Z-fighting is when multiple particle systems are overlapping and the renderer can't reliably tell which to display in front of the other. This can show as flickering, especially when the camera moves. We can avoid this pretty easily by simply offsetting the particle nodes causing trouble, which is often a good idea anyway. In this case, I thought it looked better to have the smoke a little higher than the fire. This means that as long as the particles are viewed from a higher angle, they will draw in the correct order. But of course, if I view from underneath, the fire still pops in front. Luckily, there's a setting that is meant just for this. It's hiding all the way down under the visual instance, sorting. Here we can change the depth offset to make the particles reliable.
Okay. Throwing multiple particles on top of each other. Avoiding defighting. Visual instance 3D. Sorting offset.
Reliably draw on top of other objects in the same spot, which is perfect for our particle layers. Of course, we are still just drawing one layer on top of the other. Sometimes we want them to more organically blend together. To do this, if our systems are fairly similar, we can combine them into one, which can actually look even better for stuff like fire and smoke. Here's a simple fire that I made using only techniques that we've learned so far. It has 3 layers, a fire layer using this texture, a smoke layer using the same texture, and an ember layer that emits tiny particles with this texture. And then of course an omni-light at the base. And because I'm using the same texture for flames and smoke, it's actually pretty easy to combine these into one system. Except, this also means that they need to share the same material. And remember earlier when we talked about blend modes? I said that I often use add for fire and mix for smoke. If we try to use add now, most of the smoke disappears. And if we use mix, our fire becomes really flat. The solution? Pre-multiplied alpha. Pre-multiplied alpha allows us to blend between add and mix using the alpha channel.
Hmm. So it's good for effects that should add work in cohesion, such as fire and smoke. Just 1 second. Aight.
Confusing? Yes, but let me show you how. First we go to our texture and under the import settings select pre-multiply alpha. Feel free to duplicate the texture to also have a regular version. Then in the material we set the blend mode to pre-multiplied alpha.
So we have to do it in the import settings as well. Okay. That be multiplied alpha to true in import settings.
And now, when setting the color of our particles, we can use the alpha to go between mix when the alpha is high and add when the alpha is low. But how do we fade out particles then? Well, when using add, darker colors are less visible, so black colors get removed entirely. So to fade out the smoke, we simply use an alpha of 0 and a black color. It definitely takes a little getting used to, but I think it's a super cool trick. And it can create a really nice natural blend from fire to smoke just using a simple gradient with low alpha for the flames and high alpha for the smoke. In other words, our effects are starting to look pretty fire, which means that they're ready to be brought into a game. And that is actually pretty straightforward. To play a particle system through script, we get a reference to it and call the restart function. As the name suggests, if we get a reference to it.
Okay, so restart. That's how you would normally run a particle effect from a script. Scripting. Make a reference to the particle effect. Probably something like that, and then we do particle effect dot restart. Playing a single particle effect. I imagine if you want to play multiple on top of each other, we could either run restart on all of them, but we could also just make a reference to animation player where we already set up the entire animation and then play that. Might be easier, especially when there's like specific timing windows and things like that. Like he explained, he would have like a small pull in before the explosion went out. Instead of having to do like these timings in code, you can actually just use the animation player.
And call the restart function. As the name suggests, if the particle system is already playing, it will restart. This is great for one-shot effects.
Okay, so that's something to note though. If the effect already is playing, it restarts. It's not playing, starts playing.
However, sometimes we want to start and stop a particle system from emitting. To do this, we again get a reference to the system and then set the emitting property. This script, for example, starts the particle system, waits for 1 second, and then stops it again.
Okay. Play a particle effect exactly once. Turn particle effect on and off. That's when we use particle effect dot emitting true. Turns the effect on. Then we make a timer here. This, of course, this is just an example, of course. Making a timer, you could have the particle effect turn true and false on different actions, like a player hitting a switch, something like that. So this has to be good for effects that loop. I don't remember exactly what the it's one shot, right? Good for effects that are not one shot.
Now, oftentimes we want to spawn in effects as needed. To do this, we would create our effect in a separate scene and instantiate that scene at the point where we want, say, an explosion. This script, for example, will spawn an effect wherever the player.
Okay, so we have the packed scene, we instantiate it, position it, add the child. And we have to be careful if like this will work if we do it as an RPC for multiplayer, I'm pretty sure. But we have to be careful about the position before we add a child if we do it in a multiplayer spawner. This might work, but I'm not sure. There is some tricky timing to like when the multiplayer spawner is able to get the position and not of the object. Hmm. And I imagine this VFX scene here we could also have like autoplay animation player inside the VFX scene, not just a single particle effect. and then the animation player will take care of the rest as it's added to the scene. Okay, I have 10 more minutes before I have to do my first little errand today. And I will be gone like 2 hours maybe. Then I'll have 2 hours to work before dinner. Okay. We're probably not gonna have like unhandled input. We're probably gonna have like on VFX. And then we instantiate it into this VFX variable. VFX scene instantiate. Position it. On position. Something like that. And then add child VFX. Okay. I imagine this then can be singular particle effect. Packed scene can be a singular particle effect or scene with an animation player controlling several particle effects with autoplay, something like that.
It clicks the mouse in 2D space. It has an export variable called VFX scene with a type of packed scene. So in the inspector, we can choose any Godot scene. Then, if the player presses the mouse, we instantiate the scene, set its position to the mouse position, and add the effect as a child of the current node. And voila! If we play the game, we can click to spawn effects all around. But most of the time, the effects that you are spawning this way will be one-shot effects, and so it will actually look like nothing is happening, because after being instantiated, the particles still aren't playing. And so we need a way to start them. As we saw earlier, we can do this with an animation player that we set to autoplay on load, or we can do it manually through code. In this case, in our effect scene, we could create a separate script, which is just responsible for playing the effects when it's spawned. And because this scene only has a single particle effect, that would be as simple as getting a reference to it and calling restart. And now we can see the effects playing. Of course, after they finish playing, the nodes are still in the scene. And so if I keep on clicking, we will slowly clutter our tree with a bunch of invisible nodes.
Okay.
So to clean up, we can add a quick wait to the effect and then have it remove itself.
That is a very good point. Um, Make sure either the animation player or act scene script contains a queue free function if we are going to keep instantiating this scene. That's an important one.
say after 3 seconds for example. Or we can simply listen for the signal that tells us the particles are done playing.
Particles finished. Okay. Oh. Uh, hmm.
Now, a crucial part of VFX is of course audio. And the simplest way to add sounds to your effects is using the audio stream player node. If you're spawning an effect as a separate scene, you can add an audio stream player to it, assign an audio clip, and enable autoplay. Now the sound will play anytime the effect scene gets spawned. If your effect uses an animation player, you can also use it to play sound at specific moments. There's a lot you can do to get better and more varied audio, but that's beyond the scope of this video.
Hmm. I did separate my VFX and SFX nodes, but maybe I should. They're so closely tied together, like often in the same packed scene. Maybe I should keep it as one node. I could still separate the SFX and VFX script for specific things if the script gets too large. Hmm.
That said, I think sound is often overlooked in game dev, and I'd love to go into it with a dedicated video. Let me know if that's something you'd be interested in. But until then, let's have a look at an example of VFX that doesn't require sound. This cloud. I made this using a single particle system with billboard particles that display this texture. It only emits a few particles, but they have a very long lifetime. In the process material, they spawn inside a cube with a random angle. I vary their scale a bit and fade them in and out using an alpha curve. They have no accelerations, but I rotate them over time with a bit of random angular velocity.
Let's see, 3640. I'm gonna mark where I currently am. I'm gonna watch the rest of the video right now as a one shot without stopping. And then I might come back to this specific point to take notes. But I don't have time to take notes on the rest of the video before I have to go. 3640. Taking notes. Okay.
Just to make the cloud feel a little less static. So I'm using only techniques that we've used before, except for this part, pre-process. You see, if I didn't use this and we loaded up the game, the particle system starts emitting and it takes a good amount of time for the cloud to fill up, which is of course not ideal. We want it there from the beginning. So we use pre-process to simulate the particles for some time beforehand, which makes our clouds ready as soon as the game opens. Now, if for example I wanted the clouds to move across the sky, it would currently look a bit weird. That's because the particles are in world space, meaning that if we move the particle system, we are only moving the emitter. The particles already spawned stay in place. To change this, we go under Drawing and check Local Chords. Now the particles will move and rotate with the node. The final effect that I want to look at in this video is rain. This effect is made up of two layers: the falling raindrops and the impacts on the ground. The raindrops are made by emitting a bunch of particles from a large box up in the air. A common mistake here is to use gravity for the raindrops, because we think, well, that's what happens in real life. The problem with this, however, is that if we look towards where the raindrops are emitted, they will start out with no velocity, which looks really weird. In real life, when the raindrops get low enough for us to see, they will already have reached terminal velocity. So we can actually give them a flat initial velocity, and that looks a lot more natural. I'm of course using billboarded particles here, but I've set the mode to Y billboard instead of particle billboard. That's because we always want the rain particles to rotate around the y-axis, or things will look weird from some angles, like when looking down at the rain. Another common pitfall here is not adjusting the visibility AABB. See, to make things more performant, Godot will stop rendering the particles when we are not looking at the particle system, and it uses a bounding box called an AABB to determine where the particle system should be visible. So far, all of our effects have been small enough that we didn't need to adjust this. But for a huge rain system like this, we can see that if I point away from the AABB, the raindrops suddenly disappear. So to fix this, we simply increase the size of the AABB and position it to cover the entire system. We can also have Godot guess this based on our particles by going GPU particles, generate AABB. Now to create the impact layer, we need to use a sub-emitter. Sub-emitters allow us to emit particles from other particles, and we can do so at different points. For example, when a particle collides with the GPU collision box on the floor.
Ooh.
So I created this simple impact effect. To use this as a sub-emitter, I'll make it a child of the rain node and assign it as a sub-emitter. I'll then go under collision and set the mode to hide on contact. Then, right underneath under sub-emitter, I'll set the mode to add collision and the amount to something like 2 or 3. And this is the part that confuses a lot of people. Godot is not instantiating the impact particle system for every raindrop. Instead, it tells the impact particle system to emit particles at this point. In this case, 3 particles. What this also means is that the amount property in the sub-emitter is now a way to limit the total amount of particles that this system will emit. So in our case, this is the total amount of impact particles at one time. If the system reaches this limit, it will simply not emit new particles until existing ones expire. I'll set this to 5,000. And now when we play our particles, we can see that every raindrop spawns 3 impact
That's
particles.
really cool, right?
And we can of course adjust this to our liking. And it looks like the ceremonial video torch is getting dim, so I hope you feel ready to take these techniques and try them out yourself. I've made the project files for this video available on GitHub in case you want to have a closer look. In this video, we've mostly been creating 3D effects. If you want to learn some cool tricks for creating effects to use in 2D or for spicing up your UI, check out this video by my friend Pixter. Some things have changed since the video was released, but there's still so much useful stuff there. Also, if you want to add screen shake to your effects, the Shaky Dev has a quick guide for implementing that. And if you want to learn more advanced VFX techniques, check out OneUp3's many videos on the subject. Also, don't forget to check out Zenva Academy, be among the first 50 people to use the coupon code below to get 20% off the first year of your Zenva subscription. And it looks like the ceremonial video torch is running on fumes, which means that the video should wrap up right around now.
Great video. We'll make sure to check out the last section a bit closer later today.
Just to make the cloud feel
on how to add the rain and things like that, how to have the particle effects, use the local space coordinates. All right, gotta fly. Thanks for watching. Maybe I'll drop you guys off at another streamer as I leave. Mm. There's not anyone that I recognized online. Let's see if we can find a random one. Looks interesting. Maybe a game that is close to release could be fun to watch. 56 days until release. It's a game made in Unity. Let's check that one out. See you guys in a couple of hours if you want to drop by again. Have a nice day.